This is section 5.7, Inequalities in two triangles. Our objective is to be able to apply inequalities in two triangles. Okay, so the most important thing for you to understand is in triangles that have two pairs of congruent sides, so in this pair of door frames, the side of the door is the same length in each, and the size of the door is the same length in each. So what happens when we open or close the door? What happens to the angle that's right here? Well, if you're opening it, that angle gets larger, and when you're closing it, that angle gets smaller. Now what about the distance from the door frame to the edge of the door? What happens with this distance? Well, as you open it, it gets larger, and as you close it, that distance gets smaller. So this is the basis for the hinge theorem, or the side angle side inequality theorem. Now what the hinge theorem says, if two sides of one triangle are congruent to two sides of another triangle, so here we have two sides in one triangle, they are congruent to two sides in another triangle, and the included angle, so in this case A is the included angle and X is the other included angle. If those angles are not congruent, then the longer third side is opposite of the larger included side. Okay, so let's say that again in English. So we have two triangles that have a pair of congruent sides. The included angle in triangle ABC is A, and the included angle in triangle XYZ is X. So if the measure of angle A is larger than the measure of angle X, then BC is larger than YZ. So take a second and look at that on your own, okay? And try to see if you can see it. Okay, so now we're going to use the hinge theorem. So it's asking which of the following statements must be true. And it looks like they're asking me if one side is longer than the other. So yes, that is what they are asking. So let's see if we can even use the hinge theorem. So let's see. Segment SA is congruent to segment OY. How can I tell? Because they have the congruency markers. So now let's see. AK is congruent to OU. How do I know? Once again, they have the congruency markers. Now what is our included angle? Well, in triangle SAK, our included angle is angle A. And what about in triangle OUY? Our included angle is angle O. Are these two angles congruent? They are not. Okay, which angle is larger? Angle A is greater than angle O, because 90 degrees is larger than 70. So it wants to know which side is longer. Well, I know that SK is longer than YU. So I know this side is longer than this side. So let's go see what my choices are. AS is less than YU. Well, we can't draw any conclusions about that. We can only draw conclusions about the side opposite of the included angle. Now let's look at SK. Okay, here's SK. SK is less than YU. Well, that's not true because we just figured out that YU is the smaller one. Okay, let's look at D. AK is equal to YU. Well, that's not true. We have no, it could be true, we just have no way of knowing it. And let's see, SK is greater than YU. Now this one, I can say that's true because SK is opposite of the 90-degree angle and YU is opposite the 70-degree angle. So I know that this is where I need to go. Okay, so now we're going to apply the hinge theorem. The swing ride. The diagram below shows the position of the swing at two different times. As the speed of the swing ride increases, the angle between the chain and segment AB increases. As the rider is farther from point A, is the rider farther from point A at time 1 or at time 2? And explain how the hinge theorem justifies your answer. So let's take a minute and think about this. So does the distance from point A, B, does that change? No, that maintains its distance. What about the chain that the rider is attached to, that the swing is attached, segment BC? Does that increase? No, it does not. So what does increase? Well, this angle right here at B. So right here, this angle increases. So if AB stays the same in both and BC stays the same in both, at which point is the rider furthest away from point A? Ride time number 1 or ride time number 2? I'll give you a second to process. Okay, so we are going to use the hinge theorem. Is angle B greater at time 1 or at time 2? It's greater at time 2. So I know that the rider is going to be further away at time 2 because of the hinge theorem, because AB stays the same and BC stays the same. So the only thing that changes is my angle. And as my angle changes, you'll notice my distance from A to C gets longer. Okay, so now we're going to take a look at the converse of the hinge theorem. So the converse of the hinge theorem says if two sides of one triangle are congruent to two sides of another triangle, again, this side is congruent right here, AC is congruent to XZ, and the third sides are not congruent, BC is not congruent to YZ, then the larger included angle is opposite the longer of the third side. So if I can say that BC is larger than YZ, then I know that the measure of angle A is larger than the measure of angle X. We did something like this in the previous lesson, remember? So the shorter the side, the smaller the angle. The bigger the angle, the bigger the side, the bigger the angle. So you can work back and forth. So the larger angle has the longer side. The larger side has the larger angle. The smaller angle has the smaller side. The smaller side, smaller the angle. Okay, this is our last problem. We're going to use the converse of the hinge theorem. So the first thing they want to know, what is the range of possible values for x? So I'm going to go and I'm going to look at my diagram and I'm going to see, where is x? Okay, so x is associated with angle SUT. Now what do I know about angle RUS when I compare it to angle SUT? Which one's larger? Well, I know that the measure of RUS is larger than the measure of SUT. How do I know that? I know that because of the opposite sides. My longest side is 15. My smaller side is 10. Now I know I can use the hinge theorem because RU is congruent to TU and SU, that's a shared side, so I know those are the same. So that is how I'm able to use the hinge theorem. So let's write down what we know. I know that the measure of angle RUS is greater than the measure of angle TUS. Well, what is the measure of RUS? Well, that's 60. So I know that 60 degrees is greater than 5x minus 20. Now, why am I choosing, I'm looking for my upper limit? How do I know that 60 is my upper limit? Because angle SUT has to be smaller than 60, right? So now I'm going to, let's see, add 20 to both sides. So I have 80 degrees is greater than 5x. I'm going to divide both sides by 5. So I get 16 is greater than x. So that's my upper value. So now I need to find my lower value. Now what's the smallest value that it could be? Or what do I know that the measure of angle TUS is greater than? I know that the measure of angle TUS must be greater than 0. If it's not bigger than 0, then I don't have an angle. So I've got 5x minus 20, and I'm just plugging this in because that's right there. I'm using my substitution property. It's greater than 0. So now I'm going to add 20 to both sides. So I have 5x is greater than 20. Divide both sides by 5. So I know that x has to be greater than 4. So I know that x has to be greater than 4 degrees, and x has to be less than 16 degrees. Now what does that tell me about my angle range? So we were just finding the x values, so this is our answer. But if we wanted to find out what those values meant, how would we find them? We would plug it in here into this equation and get that answer.